Okay, as promised, I will work out a few of last night's homework problems in case after seeing my solutions in class you were still having trouble. So I didn't go over 1, 2, or 3 in class today. I thought I'd start off by comparing problem 2 to problem 3 and just show you where to go for problems like that. So in problem 2, I see that I have the sign of positive x and the cosecant of negative x, whereas in problem 3, I have the secant of negative x multiplied by the cosine of positive x. When you're working with identities, the argument of the trig function, meaning the angle, it needs to be the same. So if one is positive x, the other should be positive x as well. Since cosecant is an odd function, I know that I'm going to rewrite cosecant of negative x as negative cosecant positive x. Whereas, if you look at number 3, I see that I have the secant of negative x, but the secant in this case is an even function. So my first step would be to rewrite that as just the secant of x. I can do that because the secant is even, and for even functions you're going to just eliminate the negative. So let's finish off number 2. I would use a reciprocal identity. Notice that these divide out, and I would have negative 1 over positive 1, or just negative 1. In problem 3, again, use a reciprocal identity. Divide out, and you would have positive 1 over positive 1, or just 1. All right, let's move down, and maybe we can do 5, 7, and 9 together. So if I were you, I would compare the problems. So look at problem 5, for example, compared to problem 7. In problem 7, I have a trig function being squared. So like right away, I'm thinking Pythagorean identity. However, in problem 5, I don't have that. So we mentioned this in class on Thursday. The second you're asked to verify an identity and you see one trig function next to another trig function, just a single function multiplied onto another single function, my suggestion was to use either reciprocal identities or quotient identities. So for the cotangent, I know that reciprocal identity is 1 over the tangent. And if I would substitute in 1 over the tangent, it wouldn't be very helpful, would it? Because nothing's going to divide out or simplify into anything usable. So let's pop down to the quotient identities, and I see for the cotangent of theta, that would be equal to the cosine of theta over the sine of theta. So think ahead, if you would make that substitution, would it be helpful? Well, yeah, I think it would. So I accidentally changed the variable from u to theta, but that's okay. You can do that if you want. So once I actually do the substitution, I can see that I can divide out the sine function on the diagonal. And I would have the cosine multiplied onto 1, so just cosine theta, and then my denominator would just be 1. So cosine is equal to cosine. Let's try the next one. So number 7, do we have one trig function being multiplied onto another? No, we don't. But we do have the number 1 and a trig function being squared. That's the signal to hone in on the Pythagorean identities. So this is the Pythagorean identity that involves the sine squared. It doesn't look quite like what we have in problem 7. However, if you would subtract the sine squared of theta off from the left and the right side of that identity, you can rewrite it in a form that's going to be useful to us. So I see the cosine squared and 1 minus the sine squared of theta are equivalent. So anytime I see 1 minus sine squared of theta in a problem, I could just replace it with the cosine squared of theta. So let's do that. I'm taking this and I'm going to replace it with the cosine squared of theta. Remember what it means to square a value. It means to multiply it by itself. So cosine squared would be just cosine multiplied by cosine. Those would divide out, and we're just left with the cosine of theta. Lucky us, that's what we have on the right side, so we verified the identity. So our goal is always to make the left side of the equation match up with the right side of the equation. Let's try one more on the front of the paper. Right away I see trig functions being squared. I'm thinking Pythagorean identities. And I'm looking, I guess I rewrote this one earlier today. 1 plus the cotangent squared is equal to the cosecant squared. If you move the cotangent squared over, just like we did with the sine squared in that first Pythagorean identity, you're going to have 1 is equal to cosine squared of theta minus cotangent squared of theta. So this numerator can just be replaced with 1. And I would have 1 over the secant of theta. When I have a fraction like that, I'm thinking about my reciprocal identities, and I know that 1 over the secant of theta is equal to the cosine. So that's a substitution that I can make. And just like that, we verified the identity. I went over number 10 today in class, but I think it's worth going over again. So if you didn't get it the first time around, let's take a second look at it. Okay, so problem 4 and 5. We have a single trig function being multiplied onto another single trig function. We look at reciprocal and quotient identities. Problem 7, 8, and 9, we have trig functions being squared, or the number 1 in a trig function being squared. Our first focus would be on the Pythagorean identities. When you have problems like 10 and 11, and you see one binomial set of parentheses multiplied onto another, I think FOIL, just like algebra, let's go ahead and multiply out, distribute twice, reverse factoring, however you learned it. So we would have secant multiplied by secant. That would be the secant squared of theta. Well, x, I keep saying theta. Secant multiplied onto negative 1. Positive 1 multiplied onto the secant. Positive 1 multiplied by negative 1 is negative 1. And don't lose the denominator. Whenever we multiply conjugates like this, I know my middle two terms will always add to 0, and they do. If you look, the secant squared of x minus 1, that is right here, our middle Pythagorean identity. So I can replace secant squared of x minus 1 with the tangent squared of x. So far we did everything that we've practiced for the last 2 days. When we see parentheses, we multiply. When we see a trig function being squared and the number 1, we try and do a Pythagorean substitution. Now this is new to us. We have the tangent squared over the sine squared. So when you hit a roadblock and you just, don't know what to do, a last resort is always to convert everything into sines and cosines. So what does that mean for this problem? Well, first of all, I'm going to have to go up here because I need more room. But I know the tangent is equivalent to the sine over the cosine. Therefore, the tangent squared of x is equivalent to the sine squared of x over the cosine squared of x. So make no mistake, this sine squared I didn't work with yet, but that tangent squared was replaced with that fraction. Now we have division, so I'll put the division there, and then the sine squared. If you want, you can think of that as sine squared over 1. You learned way back when you have a fraction being divided by another fraction, you do that division by changing it to multiplication. So we would take the top fraction and we multiply it by the reciprocal of that denominator. Notice how my sine squareds are going to divide out, and I would have 1 over the cosine squared. So be careful because I'm sort of running out of room here. I don't know why I wrote so big. 1 over the cosine squared is equal to the secant squared of x, and that's exactly what we wanted at the end of our problem. So that was our finish line. Problems like 12, 13, 14, and 15, there is no finish line, right? You can look through my solutions that I handed out in class if you want, just for extra practice. On our quiz next Wednesday, we won't have problems like 4, 5, 6, or 7, but there's still good practice. The other thing I want to remind you is on the quiz next Wednesday, you will be able to use the identities. In fact, I'll give you an identity paper that has the reciprocal, quotient, and Pythagorean identities in addition to the cofunction identities. All right, well, good luck with problems 43 through 46 on page 287 in the textbook, and also good luck memorizing the unit circle for the unit circle quiz on Monday.